So in this video, we'll be walking through the important inventions and people in the history of computers. Now listed on the screen are the main periods in history that we're going to be covering. We're going to start with early information processors, so before computers started, and then we're going to talk about the first computers as well as talk about how computers have transitioned all the way through what computers really look like today. And if you follow along in your notes packet, you'll be able to fill in all of the key information for each generation as we walk through the notes. So to begin with, the one thing that you need to know about these early information processors that we're going to cover is that most of these early information processing machines were used for arithmetic. So they were used in order to complete math that typically consisted of adding, subtracting, multiplying, and dividing. Now you might be surprised to hear that the first information processing device was actually used a long time ago in ancient times, and it was utilized for addition. I'm sure you've heard of an abacus before, and an abacus was used as early as 5000 BC. And while it doesn't actually count or do anything for you, essentially what this abacus did is it allowed humans to track their counting. So if they were counting a lot of items and didn't want to lose track, they would utilize an abacus because each one of these rows, so for example, this first row was the ones, and they would count 1, 2, 3, 4, 5, and when they reached 5, they would move this bead over. Then they would count 1, 2, 3, 4, 5 again, and move this bead over to signify 10. And then they would keep going through that process. So they would have ones, tens, hundreds, and so on, and essentially what this abacus allowed them to do is to count very, very quickly, and they could still perform some basic addition as well. So that's really what this abacus was used for, and while it doesn't seem very intense, it was really the first information processing device that we had. Now while the abacus was used in 5000 BC, the next information processing device that we really utilized was the printing press, which was invented by Johann Gutenberg in 1458. So it took a long time for us to develop a new type of information processing device. And essentially what this would allow us to do is it used wooden or metal pressable letters with ink on them that could essentially print onto paper or cloth. So this device was really the first thing that they were able to utilize in order to mass print information in a more effective way than just rewriting it out to distribute, a piece of text or information. The next device that we're going to look at was invented in the 1600s, and it's called Napier's bones. And from looking at this the first time, you probably don't really know what it does. But what you can do here with these numbered rods is you can actually perform multiplication on any number as long as it's that one number times the numbers 2 through 9. So if you look here at the example in this particular picture, you'll see that we're taking 46,732 and we're multiplying it by any number, essentially 1 through 9. So if we take a look here at this example, what you'll notice is, say we wanted to multiply this by 2. So if we want to multiply 46,732 by 2, we go through and we add together the numbers that are together in diagonal columns. So what you'll notice here is that on the 2 column, so we're focusing here in this block, we're going to add together the numbers in a diagonal. So we have 8 plus 1, which is 9, 2 plus 1, which is 3, 4 plus 0, which is 4, 6 plus 0, which is 6, and 4 to end the number. So what that tells us is that 46,732 times 2 is equal to 93,464. And if you do that on your calculator, you'll discover that it is correct. So Napier's bones were used to do some fairly complex multiplication back in the 1600s. Next, the slide rule was invented in the 1630s by a man by the name of Wilhelm Hollerith. And this was primarily used for multiplication, but it was also used for division, which makes it different than Napier's bones. In addition, this particular device was actually used pretty commonly up until probably the past 30 years. So if you were to talk with your parents depending on your age, maybe your grandparents, odds are that they had to utilize a slide rule within their classes. Believe it or not, I actually own a slide rule because I have an adult in my life that found one that they utilized back when they were in school. So all you need to know about this device is that it was primarily used for multiplication and division. You would line up these numbers in a specific way, and it would help you to perform multiplication and division more efficiently. Now, if we move forward to the 1640s, Blaise Pascal, and depending on your math exposure, you may have heard of Pascal's triangle. This is the same guy. So Blaise Pascal developed the Pascaline in 1641. And this is the first thing that more started to resemble kind of our calculators. Now, obviously, it looks a little bit different. But how this worked is that you could perform addition by turning and operating the various dials within this device. And it would actually perform the addition problem that you would input into it using the dials. Now, if we continue to move throughout history, in 1673, a man by the name of Wilhelm von Leibniz developed the Leibniz wheel. So, where Pascal's calculator back in the 1640s was only able to do addition, Leibniz's calculator was actually able to perform all four standard operations. In addition, his particular device was a little bit more advanced, and instead of operating by turning dials, it would operate by turning a crank that would help you to complete these four standard operations. If we move to the 1800s, the next main device that was created that resembled an information processing device was the Jacquard Loom. And this particular device was able to process information by utilizing punched cards to control a pattern woven into clothing materials, which to me is quite fascinating. So here you can see the punched card system that is on the loom itself, and it would be able to follow instructions based on this punch card system and then actually weave a specific design into its looming device, which is really kind of cool. If any of you have seen old player pianos where they had like a sheet of paper that would run through with different holes and different combinations, and then the piano would run the paper and play the music, this was a similar device to that. So if you've seen one of those player pianos, this loom was actually quite similar to the player pianos that people used to have in their homes, so the pianos could play music using these instructions written on punched cards. So as we enter the 1800s, we haven't actually seen a computing device yet, but we've seen a lot of information processing devices. And the man who really changed us from information processing devices to computing devices was a man by the name of Charles Babbage. And he was known as the father of computers because of the contributions that he made to the computing world. So as we talk about his inventions, you'll see that he was really the first person that started to brainstorm what a computer could be, what a computer could look like, because obviously computers didn't exist back in the 1800s. So he was the first man that really had this vision for what a computing device could be, which gave him the name Father of Computers. Now, while Babbage had a number of inventions, his first main invention was the difference engine, which was invented in the 1820s. And what's really interesting about this particular computer is that this project was actually abandoned. Babbage never actually finished this project. He had this vision that he wanted to design a device that could provide math tables. So he was thinking outside of the box about what it could be. And he wanted to create a mechanical device that would be powered utilizing steam. And while he had a really, really great idea, essentially Babbage was ahead of his time. He didn't have the devices necessary or the materials necessary to actually create this particular device, because it was too difficult at the time to make the small parts that were needed for the machine. But his idea of the difference engine is what kind of started to get us thinking about computers. Now, after Babbage abandoned his idea of the difference engine, he moved on to creating what he called the Analytical Engine in 1833. Essentially, he had a better idea, and he decided to move on from his previous idea and start to try to create this better idea. His goal was to create a machine that could do any mathematical calculation. And his goal was to make this machine powered by punched cards, similar to the loom that was created back in the early 1800s. Finally, similar to the difference engine, this would also be powered by steam. Now, what's interesting is Babbage gave up and abandoned his first idea of the difference engine. What he encountered with the analytical engine is while he had a better idea, he again had limitations when it came to the machine parts. He didn't have enough small parts to actually make this work. It wasn't possible in the 1830s. However, even though he never finished this design, this particular design of the analytical engine literally became the basis for modern computers. And it's because of this device in particular that Babbage is known as the father of computers, because he really had the first idea of what a modern-day computer would be able to do. Now, working with Babbage was a woman by the name of Lady Ada Lovelace. And Lady Ada Lovelace is actually known as the world's first computer programmer. And Lady Ada Lovelace was given this name because she designed a sample program for Babbage's second machine, the analytical engine, on punch cards. And because she designed this sample program for that device that's viewed as really the first computer, or it's viewed as the computer that's the basis for modern technology, because she designed the sample program for that particular device, she was given the name the first computer programmer, because she really designed that first program. And even though the program was never run, she did design it and write it to be run through that machine when it was finally ready to be run. Now, the next man in history that you need to know is a man by the name of George Boole. And George Boole is so important because he basically helped us to design and create machine language. We know that computers can only read on and off true and false switches because they cannot interpret meaning behind anything. And George Boole came up with the idea of using a 1 to describe the value of true and a 0 to describe the value of false. And this is something that's utilized not only within machine language to mimic, true or false on and off, but it's also utilized in programming when we have Boolean logic, where we want to make a variable true or false. So it's this simplistic yet genius idea of utilizing 1s and 0s to represent true or false that resulted in Boolean logic being named after him, as well as the Boolean symbols being named after him. Now, after Charles Babbage, a man that had the next big impact on our computing world is a man by the name of Herman Hollerith. And what Herman Hollerith developed back in the 1890s was he developed a tabulating system for the 1890 census. And while this might not seem like a very big deal, the country was growing. And in order to create a census, it would take a very, very long time because they didn't have a system to actually calculate and tabulate the census. So they would have to do this all by hand. And essentially what was happening is that the census was taking longer and longer to complete, and it was reaching a point where the census that was taken every 10 years was going to take more than 10 years to actually tabulate. So it wouldn't be possible to make it accurate. So this tabulating system that was created by Herman Hollerith used punched cards and essentially allowed us to perform our census in a much more quick and efficient way. And while he eventually left the census to create his own tabulating company, this particular device was quite life-changing in our country's history. Another notable thing about him is that he eventually left to create his own company, which eventually became known as IBM. So at this point, we're now into the 1900s, and we've seen a development of different computing devices and different ways that computing has started to impact our society in a positive way. And in 1944, one of the first mechanical devices that was utilized, known as the Mark I, was developed and utilized during the World War II Manhattan Project. And this particular device was based on Babbage's ideas, but it was a mechanical device that was powered by electricity. So it was a little different than Babbage's, as his was powered by steam, but this one was powered by electricity. And similar to Babbage's ideas, this particular device ended up being powered by punch cards. So we're now finally starting to have the machine parts necessary and the ability to create Babbage's idea from the 1800s. Now, if you look on this slide, I've included some pictures of the Mark I. You'll notice that it doesn't really look like computers that we've seen today. You'll notice it's quite large. I mean, it's taking up tons of space in what appears to be multiple rooms. And that's what computers were back in the 1940s. They were very, very large devices that took up a lot of space in order to complete the calculations that they were being asked to complete, and the Mark I was no exception. So it took us from about 5000 BC up until 1945 to finally start developing what looked like our first generation of computers. So prior to the 1940s, we really were only seeing those early processing devices, but finally, starting in the 1940s through 1959, we're going to see our first generation of computers. And what characterizes the computers are that first, they were electronic devices. Secondly, they utilize what were called vacuum tubes in their circuitry. So instead of utilizing punch cards, we're going to use these vacuum tubes, which you can see right here, that look kind of like light bulbs, that will essentially become on and off switches. Whereas before, we had, punch cards with holes in paper that indicated on and off. We now have something that works like a light bulb that will actually heat up and shoot electrons that will indicate on or off switches. So that's what our first generation of computers utilized. They utilized vacuum tubes. Now, the first electronic computer that utilized vacuum tubes was made in 1946, and this was called the ENIAC. Now, ENIAC was an acronym that stood for Electronic Numerical Integrator and Computer. So you can see we're calling this the ENIAC was a lot easier. And this is the first electronic computer that utilized these vacuum tubes. So we're no longer utilizing those punch cards. And you can see that similar to the Mark I, this ENIAC computer took up an enormous amount of space. Now, to give you some insight and fun facts into the ENIAC, it was primarily used to calculate artillery firing tables. And the reason that this was so life-changing for them to have this computer is that the ENIAC could follow instructions very, very quickly. While computers need to be told what to do, they can do things much more quickly than a human. So the calculations that would typically take the humans 20 hours to do only took the ENIAC computer 30 seconds. So they were able to save a significant amount of time by utilizing these computers. The problem is that by the end of its operation in 1956, this particular computer had grown to include 20,000 vacuum tubes. And I don't know about you, but when I think about 20,000 light bulbs go out fairly often. And so if one of those light bulbs went out, the entire computer would not work as it was supposed to. And they would actually have to go through and find where that particular, vacuum tube burnt out and replace it. So you can see how, while this was a great device and it had a lot of power, it wasn't necessarily the most efficient device. Now, at the same time that computing devices were developing, a man by the name of John von Neumann created a new concept for storing a computer program. And essentially what he did was he created a program that was read from punch cards in computer memory. And he represented this using machine language, which is our binary values, which you'll learn consists of ones and zeros. Now, in addition to this, he also designed what is called a serial processor. And essentially what a serial processor does is it executes commands one at a time sequentially, which based on our programming knowledge already, that's kind of what all of the programs we've looked at recently have used. They've all gone one statement at a time in a row, utilizing a sequential set of commands. And so the serial processor used this exact same thing. And this particular thought process became known as the John von Neumann architecture. Now, after the ENIAC was created in 1946, the next major computer that became well known in our history was developed in 1949, and it was called the EDVAC. Now, EDVAC stands for Electronic Discrete variable automatic computer. So you can see we're using the acronym again of EDVAC was a lot more efficient. Now, what's really interesting about this particular computer is that this was the first computer that was made to utilize binary. So this is the first computer that used John von Neumann's idea of a stored program in binary. So where the ENIAC had everything stored in decimal, the EDVAC actually stored information in binary, which is how information is stored in computers today. So the EDVAC computer was really the start of the use of binary within computing devices. If you look in the pictures that you see here, you will see that this particular device still utilized those light bulb looking vacuum tubes. So it was similar to the ENIAC in that way, but its main difference was the fact that it utilized binary to store and represent information on its computer. Now, so far throughout our history, there are major computers that have been created, but none of these computers were actually commercially produced. And in 1957, we finally saw our first commercially produced computer called the UNIVAC, and they called the UNIVAC 1. And this stood for Universal Automatic Computer 1. And this computer was the first computer that was actually commercially produced and became the first general purpose computing devices for business applications. Now, the one other fact of information that you should know about this computer is that it was continuously used by the Census Bureau until about the year 1963. So as you can see, while it took a long time to start developing our first computing devices, it took us, from 5000 BC to 1945, the first generation of computers that utilized vacuum tubes had a pretty short life. It lasted from about 1946 to 1959, so only about 13 years. And after 13 years of those first generation computers, some changes were made. What they realized is that those light bulbs didn't really allow for miniaturization of anything. It made the computers very, very large. And so as a result, they switched to something called a transistor. And so these computers in the second generation utilized transistors, and what these essentially did was they allowed for some miniaturization of these computers, which was incredibly important for the space program to be able to grow, as a space program computer could not support the current size of computers. The other thing that was really nice is that these transistors, as you can see in this picture, are not light bulbs. So whereas the vacuum tubes and the light bulbs would burn out, transistors would not. So they wouldn't have to worry about constantly replacing these pieces of hardware in order to make the computer run. The other thing that was unique about these computers in the second generation is that their internal memory was made out of magnetic core materials. So we've started to change what we're utilizing to make our computers with. Now, a woman by the name of Grace Hopper really had an important impact on the second generation of computers. Grace Hopper was a Navy officer first assigned to programming the Mark I. So she was a part of computer science back in, the 1940s when the Mark I was being utilized. And as she continued to grow with computer science, her big contribution to computer science occurred when she created the first compiler that allowed us to translate a program into machine language. So this addition of a compiler really jump-started the high-level programming languages that are utilized today. So she's credited with creating that compiler that allowed us to translate a high-level language into machine language so a computer can actually read it. Now, some other important developments within the second generation of computers. The first is that assembly language, which is that mid-level language, was developed, and it used what looked like symbolic code to represent some binary notation of machine language. So assembly languages started to develop and become commonplace. In addition, the first common high-level languages were developed to run on many different computer types. So this is where Grace Hopper's contribution of a compiler was so important. And those first high-level languages that were created were called COBOL, and that should be Fortran. The other important thing that you need to note about second-generation computers is that they were smaller, so that they were more easily used in smaller spaces. You didn't need to have a big room or a big building in order to have a computer. They were faster, so that they were able to process more information. And in addition to that, they were more powerful and required less energy to operate because you were no longer turning on and off those light bulb-like vacuum tubes. Transistors didn't require as much energy as the vacuum tubes. So in general, these computers were just getting better and better. Now, whereas the first generation of computers was characterized by those vacuum tubes, and the second generation of computers was characterized by transistors, this third generation of computers is characterized by what are called integrated circuits. And essentially, all an integrated circuit is a silicon block that consists of hundreds of transistors. So in the third generation of computers, in the mid-60s to early 70s, we were finally able to put hundreds of transistors on one silicon chip. So this particular image here kind of gives you a visual of the first three generations of computers. This first piece right here consists of vacuum tubes. And you can see there's 1, 2, 3, 4, 5, 6, 7, 8 vacuum tubes here in this particular picture. Now, as we continued to develop things for computers, we moved to transistors, which you can already see are smaller. This particular block right here has a lot more on and off switches, and it's taking up a lot less space. And then finally, in the third generation of computers, we moved and put hundreds of transistors onto this integrated circuit, which is just a silicon chip. So you can see how we've gotten smaller and smaller and smaller, which ultimately has led to computers being things that we can carry around in our own hands. Now, as computers continue to develop in that third generation time frame, some other notable developments. First is that the auxiliary memory devices and input-output devices were starting to be introduced. So these were starting to be things that we could add on to our computers. In addition to that, something by the name of the ASCII code was developed and essentially allowed us to use binary to represent key keyboard characters. The third notable development here is that the BASIC language was developed during this time frame, and it was developed as what's called an interpreter language. So now in the 1970s, we finally reached the fourth generation of computers. And what you're going to notice as we keep looking at the upcoming generation of computers is that we really just took that idea of integrated circuits and we continued to develop and make it better. So in the fourth generation, we essentially had large-scale integrated circuits that are now known as microchips. And instead of just holding hundreds of transistors, microchips could hold tens of thousands or more transistors on a single chip. So we're essentially just able to make our integrated circuit smaller and smaller and smaller, which is allowing us to create smaller and smaller and smaller computers. Now, two other important developments from the fourth generation of computers. The first is that Apple had started to dominate the microcomputer market in the 1970s. So this is where Apple really started to grow as a computer company. Secondly, many new powerful programming languages were being developed, and three notable ones are Pascal, C, and Forth. And what you'll notice is that we've continued to develop powerful programming languages since then. Now, on our fifth generation of computers, which consisted of most of the 1980s, we were developing better integrated circuits. You'll see we're calling these very large integrated circuits. And we're now able to include hundreds of thousands of transistors on a single chip. And our processing speeds were continuing to improve, and we were at a point where we had over 1 million instructions per second running on a computer. Now finally, we've reached the sixth generation of computers, which we can start in the 1990s and say continues until now. And essentially what we've done since the 1990s is we've taken very, very large scale integrated circuits that contain millions of transistors on a single chip, and we're able to run trillions of instructions per second. And we continue to make these computers faster with more transistors on those integrated circuits that are resulting in computers that are better and better and better, but also smaller and smaller and smaller, which is why we now have computers that we carry around with us every day in our back pocket called our cell phones. Computers have gone from large-scale room computers over the generations all the way down to a device that we can carry around in our hands.